Welcome to Renesas AI Insights. I'm your host, Vin D'Agostino, and today we're joined by Jeff Saraki, who is the Director of Engineering for the Renesas AI Center of Excellence. Hi, Jeff. Welcome to the show.
Hey, Vin. Great to have you here.
So I have a number of questions that we have collected from customers who are looking at making the plunge into AI or customers who are considering different things. And I just thought I'd run them by you from a technical perspective, if that works.
Sounds great.
So I think the first thing and very fundamental is if you had to define AI in layman's terms, how would you do that?
Yeah, AI or artificial intelligence, it means a lot of things to different people these days. But in our application, we're talking about really data-driven engineering, tools that can learn from example to make a decision and then ultimately be deployed to make similar decisions automatically.
If I were a customer and I'm doing this for the first time and I don't know anything about it, should I be afraid to commit my future product development to AI?
Absolutely not. But as part of that commitment, it's critical to consider the process, right? To commit to a careful data collection plan, testing, iterative expansion, and lifetime management. Our approach really is to support the customer all through the process so that we see success, right? We don't just want to give them the keys to our tool and say good luck. We want to really see an outcome that's pleasing to everybody.
You hear people all over the world talking about AI and talking about AI taking over the world and controlling humans. Number one, is that even possible? And number two, is the stuff we're talking about in terms of applying AI, is there any fear of that?
Any powerful technology has the risk of abuse. But in the case of AI, I think we're really confused by decades of experience with bad sci-fi plots, just putting it in a light that isn't appropriate. It doesn't really match up to the technology we call AI today. And in the specific case of what we're doing, the AI we're producing, we're putting in small microcontrollers, it's not of the same scale or capability as even things like ChatGPT and generative AI that you're hearing a lot about. Instead, these are very bespoke modules that make one decision or a few decisions and do one task very well. They're not general purpose thinking machines, right? They're designed to sit in a small piece of silicon. So with that technology, there's really no path by which your toaster or your air conditioner is going to help take over the world. There just isn't.
Okay. I'm sure this varies with every problem you're trying to solve. But someone who's starting to do this, what should they consider in terms of resources for both cost and time to develop data collection and AI models that will be reliable in their product that they send to their customer?
Right. So in AI engineering, data collection is by far the largest component of your budget, right? It might be 80% of it. But as you're saying there, it really depends very much on the application, right? You might have a safety sensitive system where there's a very high bar for validation. That's going to be a lot of testing. Is it very easy to create the conditions you're trying to simulate? For example, clogged filter, that's not too hard. But if you're trying to simulate breakdown in a cooling system or a high voltage system, that's going to involve specialized lab equipment and technicians, and that's much more expense. Likewise, if your problem involves a lot of variation in background noise or environmental conditions, that's also going to increase expense. So everything becomes a factor, in considering the overall cost.
Okay. Let's assume a customer has been using microcontrollers for a long time, and a traditional if-then-else kind of algorithm typically solves their problem. If that's true, does AI add anything to the equation, or does it just make it a different and more complex way to solve it?
We like to see AI as an engineering labor-saving device, right? It's not a replacement. It's really data-driven engineering. It supplements the traditional approaches rather than replacing them, right? It can be very time-consuming as an engineer to start building models and going into the laboratory to determine just what to put in that if-then statement. So if your AI can analyze your data and determine that, for example, a few side lobes in this particular FFT are the critical decision factor, then why not leverage that, right? We've had many occasions where we've gone to new customers and they've actually given us a test problem that they've already solved. In cases like that, what's really interesting is we'll go in and a week later we'll have a fairly accurate solution that took them a year and a half to create by traditional methods. And that really makes a good impression.
That's a really good way to look at it. I think a lot of people might say, what I have is good enough right now. What am I going to gain by making this investment? And it sounds like incrementally, there are a lot of ways that people can take advantage of this and either improve their business model or improve the product that they're delivering to their customer base.
Absolutely, right. We break it into several pieces. We consider what features you're extracting from the data to make the decision, and then how you architect the decision engine itself. And as part of that process, we actually try to expose to the engineer as much as we can about how we solve the problem. We try not to make it a black box. So if at the end of the day you discover something you didn't know and you can do it with an if-then statement, that's fine.
So what would you tell a customer who's considering doing this, but they're already resource bound in their engineering department? How would they go about getting on the path to adding this technology?
So we can make very specific recommendations about things like overestimating your data collection so you don't have to go back and do things twice and waste time, and constructing projects in a way that you gate based on some early POC results that are meaningful, meet some milestones before you make a bigger commitment. So I think that's probably the best way of handling sort of limited resources.
Can you talk a little bit about someone who's never worked in this area at all, how they should prepare themselves so that when they embark on this journey, they're successful the first time?
Planning. As we've been discussing already, a good data collection plan with proper, carefully controlled coverage of real-world variation is going to be key to believing this works and to seeing it generalize and work in the real world. We're not trying to produce something that only works on a benchtop. But that said, we still want to gate the process, right? We want to start with a POC that proves something, proves the idea is valid, and then move forward from there and build on the first result.
Cool. All right, so now we have our product developed, everything is fine. Now we're going to go try to sell it. How can a company highlight and show the value proposition of this AI that they've just added to their product for their customer?
Right. There's a couple dimensions to that. I mean, obviously AI, it's a buzzword, it's a hot topic. So just having that as marketing is going to be important to some. But from an engineering perspective, I would focus on capability. Because what we're able to do with AI is we're able to put new features, capability, smarts, if you will, in much smaller places that it wasn't possible before. So that capability, that's really what Edge AI is about.
Cool. Okay, one final question. We have an engineering culture, right? And it's shifted to fail fast, fail often. In a culture of fail fast, fail often, how does a company ensure that they're not just burning money when they switch over to doing AI, which, as you've said, has a lot of data collection up front?
Absolutely. Again, from the engineering side, it's gating the process. Right? Let's come up with a POC, something with simple, clean, small number of classes to make decisions on that proves to you that this is feasible, that we should go forward and actually spend more money on collecting real data at scale. Because again, the collection of data is the biggest cost in an AI project. So we start small, and then we consider how to make it work in the real world with a much bigger data collection after we prove the basics.
Great. Well, Jeff, thanks for your time. I know that you're busy. I appreciate you coming and joining us for this conversation. So we've had a technical discussion about AI, and now I'd like to have a little bit of a business discussion. We're also joined today by Suad Yusuf, who is the Director of Product Marketing and Strategy for the same AI Center of Excellence for Renesas. Hi, welcome back. Now we're joined by Suad Yusuf, who is the Director of Product Marketing and Strategy for the AI Center of Excellence for Renesas. Hi, Suad, thanks for joining us.
Nice to have you here.
So I'm going to ask you a few questions that I had asked Jeff earlier, and I'd like you to answer them from the business perspective, because the people watching us are also trying to take this AI and turn it into a business, right? Or enhance their business in some way. So I'm going to start with the last question that I asked him first. In a culture, engineering culture, where we're told to fail fast and fail often, how does a company ensure that they're not just burning through money when they make a shift to something like AI?
That's a very good question, Win, because iteration is the magic word. Iteration means as more they are, as longer the time needed, as larger the cost will be. This is where we, from Renesas AI Center of Excellence, we are providing dedicated services from the very beginning with the consultancy, where we are helping exactly those customers to have a better understanding of the system. Because AI, from a technology point of view, leads to a need of mindset shifting, which means actually the way of your understanding for the system itself, and understanding exactly what are the pain points that you would like to solve by using the AI technology in the application itself. So Renesas is providing, as I said, consultancy, but also providing dedicated services in terms of working with the customer throughout the process at the very beginning, defining the specific steps needed for data collection, data analysis, and furthermore, dedicated steps in terms of finding the right model for you, and then providing also the right embedded part, what Renesas has in its own portfolio, right? So less iteration, less time, reducing the cost, accelerating time to market.
You're in product marketing, so I'm going to ask you a question about how customers can then sell this technology to their customers. Once a company has committed to AI and they've added AI into their product, how can they demonstrate or promote the value proposition of that AI component to their customers?
Very interesting question from a business perspective and also from a marketing perspective. There are several points that needs to be considered hereby. First of all, beginning with the simplicity. We need to find a way to show to the end user how simple actually the usability and implementation of AI has been done, and hereby to highlight also the benefits of AI, having those in the dedicated specific application, whatever that might be at the end. From a benefit perspective, we do talk about efficiency. We are increasing the efficiency, but also we're enhancing the user experience, which is one of the most critical and crucial actually topics that needs to be provided as a benefit to the end customer. As long as we are keeping the flow, showing all this I call it chain of benefits, because we are not talking about one. We are increasing the chain of benefits, beginning with the liability, with the simplicity, with the efficiency, so forth and so on. That's the package that the end user needs to see. For most experience, the enhancement in the daily life by using AI in the application itself.
Here's another one. This is a fun question, but I think a lot of people, this is in the back of their minds. We hear all the time in the news and in strange places that AI is going to take over the world and take over humans. So number one, in your opinion, is that even possible? And number two, the technology we're talking about here today, embedded AI, is there any risk of that happening with what we're looking at?
Yeah, I mean, that's a wonderful question. Most likely biased by sci-fi in the last 3, 4, 5 decades, because it was always a hot topic to talk about and see movies which are actually exactly showing a possible path on taking over the control by the machines. But with each and every new technology, we do have faced historically actually the same fear. Like Industrial Revolution, for example, the humanity had a fear that whatsoever is going to happen with the computer era, we had the same fear, but we haven't seen anything that the machines have taken over the control. And the same thing is about AI. The artificial intelligence right now, from the level where AI is, cannot take over the control over the world and the humanity. And for most, when we're talking, because we said the magical word embedded, for most, when we're talking about embedded systems and the way we are deploying actually the intelligence into those systems is very limited. So there is no reason of having a fear that maybe your home appliances are going to take over the control of the world, right? So,
thank you very much. I appreciate your time. Thanks for joining us. I hope to see you at the next episode of Renesas AI Insights.